factors affecting wear. The key factors influencing wear are temperature, sliding speed, hardness, modulus of elasticity, load, and composition of material. The wear resistance is influenced by the contact temperature, since the hardness and yield strength diminish as the temperature rises. Abrasive wear would increase. The yield strength and hardness for most of the materials diminishes as temperature rises. At elevated temperatures, the dislocation movement in metals causes a drop in yield strength, making plastic deformation simpler. The wear rate is substantially influenced by the normal load. With an increase in the load applied, the shear force and frictional thrust rise as well, speeding up the wear rate. In the range of 0 to 2.5 meter per second sliding speed, the rate of abrasive wear increased marginally. Frictional heating may be to blame for the increase in wear. We cannot generalize that the increase in sliding speed would definitely increase wear, as it also depends on the load being applied on the surfaces, presence of lubricant, and the surface roughness of the contacting bodies. The elastic modulus is an indicator of the material's resistance to deformation under load, with a larger number of indicating more stiffness. The material's composition also has a significant impact on wear behavior. For example, in composites, its mechanical behavior can be affected based on the concentration of inorganic fillers, the presence of organic matrix, which is responsible for low resistance to wear, can be reduced by the introduction of these inorganic fillers. Several other techniques for wear reduction include proper maintenance, varying clearance adjustments over time, good planning, integration of preventive maintenance, controlling the preventive maintenance tasks, selection of appropriate material for the component, reducing sliding pairs with the replacement of rolling pairs, using a fully automated maintenance facility. What is lubrication? Explain in detail about lubrication. Lubrication is the control of friction and wear by the introduction of a friction reducing film between moving surfaces in contact. The lubrication used can be fluid, solid, or plastic substance. Although this is a valid definition, it fails to realize all the lubrication actually achieves. Many different substances can be used to lubricate a surface. Oil and grease are the most common. Grease is composed of oil and a thickening agent to obtain its consistency, while the oil is what actually lubricates. Oils can be synthetic, vegetable oil, vegetable or mineral based as well as a combination of these. The application determines which oil commonly refers to a base oil and should be used. In extreme conditions, synthetic oils can be beneficial where the environment is of concern. Vegetable based oils may be utilized. The role of a lubricant. The primary functions of a lubricant are to reduce friction, prevent wear, protect the equipment from corrosion, control temperature, dissipate heat, control contamination, carry contaminants to a filter or slump, transmit power. Hydraulics provide a fluid seal. Types of lubrication. There are three different types of lubrication: boundary mixed and full film. Each type is different, but they all rely on a lubricant and the additives within the oils to protect against wear. Full film lubrication. It can be broken down into two forms. Hydrodynamic and elastomeric. Fluid film lubrication is the lubrication regime in which through viscous forces the load is fully supported by the lubricant within the space or gap between the parts in motion relative to one another object, and solid contact is avoided. In hydrostatic lubrication, external pressure is applied to the lubricant in the bearing to maintain the fluid lubricant film where it would otherwise be squeezed out.